All right, let's jump right into this explainer. Today, we're navigating the incredibly complex, sometimes messy world of sustainability, specifically the circular economy and industrial symbiosis. If you've ever found yourself wondering how companies actually measure their environmental impact, without just making a wild guess, well, you're in exactly the right place. Now, before we unpack the tools themselves, I want you to keep one crucial question in the back of your mind. Can digital tools just fully automate our sustainability decisions? Like, can tech do all the heavy lifting for us? Keep that rolling around in your head because it's going to shape literally everything we look at today. When we talk about the circular economy, we aren't just talking about a simple loop. We're looking at massive, massive system complexity. Picture this intricate, overlapping web of countless actors, intersecting material flows, and constantly shifting variables. It's not a straight line. It's this constant chaotic spiral that is, frankly, nearly impossible to track with just a pen and paper. So, to make sense of this whole alphabet soup of sustainability acronyms, here's our roadmap. We're going to navigate the complexity of sustainability, unpack the essential digital assessment tools, look at tracking materials and standardizing impact, explore industrial symbiosis platforms, talk about the crucial role of data, and finally, weigh the benefits versus the limitations. Starting off with the complexity of sustainability. Navigating this space is a lot like trying to find your way through a really dense wilderness. Making decisions blindly in a system this complex isn't just difficult, it's honestly downright dangerous. Because the circular economy and industrial symbiosis involve so many moving parts, human calculation alone just doesn't cut it anymore. We absolutely need digital tools to step in here. Why? Well, first, to manage that increasing system complexity we just talked about. Second, to enable true data-driven decisions, because reliable data is the absolute bedrock of any sustainability assessment. And third, to provide faster automated analysis. These tools handle the complex calculations and comparisons, so you aren't spending literal years crunching numbers just to figure out a single product's footprint. Let's move on to the essential digital assessment tools. What exactly is acting as our compass and map here? Let's open up the digital toolbox and take a look. Think of life cycle assessment, or LCA, as you'll usually hear it called, as our primary X-ray for sustainability. It lays out the fundamental principles for assessing the environmental benefits, and of course the drawbacks, of sharing resources across a product's entire life. Honestly, it's the absolute gold standard for figuring out what is actually happening to the environment when we extract, manufacture, use, and eventually dispose of things. In practice, LCA maps the entire physical reality of a given process. Think about it. Physical resources and input products go in on one side, but you don't just magically get your intended products coming out the other side. You also get emissions released into the air or water, plus physical wastes that have to be managed. An LCA basically accounts for every single drop, gram, and particle. It's incredibly thorough. But to actually calculate those impacts based on all that inventory data, industries have to rely on some pretty heavy-duty software. You've got fantastic open source options out there like OpenLCA, which makes this stuff super accessible for researchers or smaller firms. And then on the other end, you have the massive professional industry tools, programs like Gabi and SimiPro. These systems do the immense, heavy mathematical lifting required to turn thousands of raw data points into an environmental footprint that we can actually understand. But here's the catch. These software tools, they're essentially just empty shells without background data to power the modeling. You have to tell the software what the environmental cost of, say, producing 1 kilogram of steel or generating a single kilowatt of electricity actually is. That crucial background data is provided by dedicated databases. EcoInvent, for example, is one of the most prominent sources globally. They're the ones supplying the foundational numbers that make any of these LCA calculations possible in the first place. Okay. Moving to our third area, tracking materials and standardizing impact. Let's look at how all this builds when we map out physical material flows and start applying standardized rules across the board. Used right alongside LCA is something called material flow analysis, or MFA. Now, while LCA looks at environmental impacts like emissions and toxicity, MFA is all about tracking the physical flows of materials through systems. This is exactly how we pinpoint system inefficiencies. By mapping exactly where physical materials are going, we can figure out how to intercept waste and turn it right back into resources. And that is the whole secret to successfully closing the loops in a circular economy strategy. Now, when it comes to standardization, things can get really messy if everyone is playing by different rules, right? To fix this, the European Union established standardized methods based on LCA. First, you have the Product Environmental Footprint, or PEF, which measures the impacts of specific, individual products. Then, zooming out, you have the Organizational Environmental Footprint, or OEF, which measures the impact of an entire organization. Having these standards means we can finally compare apples to apples. Next up, industrial symbiosis platforms. So how do we take all these footprint measurements and actually connect the dots to implement industrial symbiosis in the real, physical world? It generally happens in two practical steps. First, we use resource matching tools. These act a little bit like matchmaking algorithms, but for businesses. They connect companies that have complementary needs and resources. For example, maybe one factory's waste heat is exactly what a neighboring facility needs to run its boilers. Second, once that match is made, digital marketplaces step in to actually facilitate the commercial exchange of those byproducts. It's these digital platforms that enable the real-world magic of industrial symbiosis. Section 5 brings us to the crucial role of data. And guys, here is the major caveat in all of this. A digital compass is completely, 100% useless if your underlying map is wrong. I literally cannot stress this enough. Poor data leads to unreliable decisions. It honestly does not matter if you have the most expensive software and the fastest computers in the world. If the underlying information you feed into the system is flawed, well, the entire assessment fails. It's a classic case of garbage in, garbage out. And this brings us to a massive, massive tension in the field, which we call the data reality. On one hand, absolutely accurate data is essential for reliable results. We need high data quality to make these huge sustainability decisions. But the reality on the ground, good, precise data is notoriously hard to find. It's often locked behind paywalls, or sometimes, especially for brand new sustainable materials, it simply doesn't exist yet. Finally, let's look at the benefits versus limitations. Weighing everything we've talked about, what are the actual pros and cons of relying on these digital enablers? On one hand, these tools offer incredible advantages. We're talking better decision support, the scalability to model vastly complex systems, and total transparency for our underlying assumptions. But we have to balance that against some pretty severe limitations. We're dealing with glaring data gaps, high financial costs for software access, and a steep, steep wall of complexity that requires serious, specialized expertise to climb. Which brings us to what is perhaps the single most important takeaway from our source material today. Tools support decisions, but do not replace expert judgment. Technology is an unbelievably powerful aid, for sure, but it is not a replacement for human critical thinking. We can't just blindly trust a computer's output without a human expert there validating the inputs, understanding the context, and making the final call. So I'll leave you with this final thought to ponder as we wrap up today's explainer. If our highly automated digital tools are accidentally fed incorrect data, are you still applying the critical expert judgment needed to catch that error? It's a fascinating challenge, and it proves that even in the digital age of sustainability, a critical human mind is still our most valuable tool. Thanks for joining me on this deep dive, and keep asking the hard questions.